Hello everyone, I'm Abu Bakar as presenter in this project. Let me tell you a few information. I'm currently majoring in naval architecture and marine engineering at Diponegoro University, Indonesia. Mr. Samuel and Mr. Zakki are as well, while Mr. Kim is from Pukyong National University, South Korea, with naval architecture and marine engineering. Okay, I think it's enough for our team introduction. Let's go ahead to the presentation with the title is a numerical ventilation problem on Fridsma half form using an overset grid system. What is NVP or numerical ventilation problem? Okay, this is the sample of NVP which happened in our study. This picture is a visualization from wet surface area that happened in Froude number 1.8. The red region is water and blue region is air. But there are green or blue flow that flow from ship boat to the ship bottom. The flow is known as NVP. Numerical ventilation problem or NVP is problem that often occur during the numerical simulation process. This problem mostly occur when the vessel has a high Froude number, causing inaccurate ship resistance prediction. The present paper aims to validate a numerical resistance prediction using Fridsma half form, and we are using commercial software from CD Adapt for this study. This graph is the result from first simulation before we give some treatment to minimize NVP. In this first simulation, NVP was found in Froude number 1 and 8, but there is no NVP in Froude number 1.5. Hence, there is inconsistency in drag prediction. But before we discussion further, let's see the method we are using in this study. We are using Fridsma half form as validation on experiment result, which characteristic can be seen in table below. And the picture is lines plan of the Fridsma half form. In numerical implementation, we use overset grid method. There are two geometries. The first geometry is background as a donor cell, and the second geometry is overset as acceptor cell. For boundary condition, we use velocity inlet for inlet top and bottom, and pressure outlet for outlet, and we use a symmetry plane for symmetry and side. For dimensional of the towing tank, we use ITTC recommendation. Uh, for we also use 2 degrees of freedom. There are pitching or y-axis rolling and heaving z-axis translation. For y plus, we limiting y plus on 55 until 60 interval for simulation accuracy, as recommended by Akshay on his study. For time step, we are using ITTC recommendation too. We also using mass density for more accurate result and to save computational time with mass based on the table below. And this picture is the mesh visualization during this study. There are a few ways to minimizing NVP. First method is by multiplying by percentage of NV. Percentage can be seen from NV percentage of NV flow to SA and percentage of the color zone. As seen in this picture, occurring NV is on 12%, which is based on the area and color ratio. Therefore, a total drag is multiplied by 1.12. This method is adopted from FC study on 2018. The second method is phase replacement. This method will replace the air phase with the water phase. The volume fraction of water coefficient which has a value of less than 1 will be replaced. The result indicate good performance based on how the color and the hull are. Here is a picture depicting comparison between before, after picture and after its lower picture of phase replacement occurring on Froude number 1.8, and numerical ventilation was perfectly replaced. The third method is mesh refinement. Mesh refinement is conducted by improving mesh quality on the water surface. In this study, there are two methods of mesh refinement are used. Refinement 1 is focused around the shape bow as shown in figure A, and refinement 2 is focused on a round shape as shown in figure B. This is the picture I mentioned before. To different both of this mesh, picture A we call mesh refinement type 1 and picture B we call mesh refinement type 2. Okay, we continue to the result and discussion. It can be seen that on the direct curve that NPV didn't occur on Froude number 1.5, which influenced the result on the first method and the second method. The result is not good enough considering the curve trend shown in the experimental result. On top of that, both of these methods doesn't influence stream and heat result. Mesh refinement type 2 show good performance with trend and error shown from earlier result. This method also influenced stream and heat result. However, on mesh refinement type 1, so that performance is not good enough compared than 3 earlier results. Some huge error occur on the heat and stream result. And the next slide will be showing wet surface area visualization from all the methods used. Here are WSA visualization from CSD with NVP, phase replacement, mesh refinement type 1, and mesh refinement type 2. Okay, the first method is multiplied by percentage of NVP. There are some things that need to be taken care from this method. First is result accuracy depends on NV flow area and color ratio. The result will be numbers on the result prediction and cannot be visualized. The result doesn't influence stream and heat prediction. For the second method is phase replacement. Something that needs to be observed in that result is less consistent if both conditions where NVP does and doesn't occur like in this study. Then percentage selection that will be replaced is also affecting the result, and trim and heat result are not affected. For the third method is mesh refinement. Things that need to be observed is that the refinement should be conducted around the offset box as shown in mesh type 2. Increasing mesh density on the bottom is good on reducing NVP as shown in mesh type 1. Result is more consistent because this method needs to reconfigure the simulation. Yep, this is the comparison between mesh type 1 and mesh type 2, where mesh type 1 density is good in reducing NVP. However, because the refinement was only conducted on the inlet of the offset box, the result is not very accurate. For mesh comparison, we tried to increase the number of mesh type 2 with 700,000 cells from coarse mesh and 1,400,000 from fine mesh. From the WSA visualization, it minimized NVP quite well, and there is no significant result between coarse mesh and fine mesh. This is the mesh comparison graph, and there is no significant result between coarse and fine mesh. On the drug result, it can be found there is a huge gap on Froude number less than 0.89. This condition is also found in Euler and Froude study, who conducted numerical simulation with Fridsma half form. So this numerical simulation is acceptable. Conclusion from this study is first, mesh refinement method is so good performance in solving NVP. On the other hand, it minimizes error in resistance prediction. Second is increasing the number of mesh doesn't have a major effect on performance result. And the last is result so that the numerical result agree well with experiment data at Froude number below 1. However, at Froude number above 1, the gap show between 7 until 9.5% total resistance. Thank you for your attention. Have a nice day.